So now that we have looked at bar graphs, we'll be looking into another experiment and another type of graph. In this experiment, the research question might be, do heavier boats sink faster? And here you could use paper boats to represent different types of boats. And you'll be adding different numbers of dimes, which are masses, to put on the paper boats to see if paper boats with more dimes will sink faster. And so here, we'll be measuring the time that it takes for the paper boats to sink, measured in seconds. And you could represent it similar to the bar graphs using a table. So you can see here that there are also different trials done to make sure that the data collected is accurate or valid. And here we did 3 trials as well. And we have the times that it took for each boat to sink, for each of having 1 dime, 2 dimes, and 3 dimes. And after we have all of the values or sinking times of the different boats with dimes collected, we could also measure the average. And again, this is done the same way, adding for each number of dime data from trial 1, 2, and 3, and dividing it by 3 because there are 3 trials. So 4.9 plus 5.1 plus 4.7 divided by 3, which would be 4.9. And you also do to 1 decimal place because all of the other data is also in 1 decimal place. And you can see here, as 4.9 represents the time of sinking by seconds, you also add this S over here, which represents these seconds. The importance of title is also over here, where you have to label what this table represents. That would be raw data again, all of the data you collected, relationship of mass of the boat over here, represented by the number of dimes, and sinking time, measured in seconds over here. But before we make this other type of graph, it's important for us to simplify or make simple the numbers we found so that we could put it into a direct relationship. So what we do is, because what we're looking into is the heavier boats and sinking time, we put the mass of the boat over here and the average sinking time over here. You can see that over here, the mass is represented in grams. And instead of putting a number of dimes, because we want to look at the relationship of mass, it's important we use units such as grams, which actually measures the mass. As 1 dime is about 2.2 grams, 1 dime kept represented at 2.2 grams, 2 dimes 4.4 grams, and 3 dimes 6.6 grams. Here, you can see that instead of me putting grams next to each of the masses, I put it on the top because it makes the overall table look more organized and easier for others to also look at. The same goes with the number of seconds. And these number of seconds are not individual number of times, but the averages, because I said that it would be best representative of all of the data I found. So because we now have this more simpler version of a table, we can put it into a graph. And this time we'll be using a line graph. You can see over here, there is the title of the graph, which is relationship of mass of boats and average sinking time. And you can see that the mass of boat is represented in the horizontal axis and the gram is also put. So there is 2.2, 4.4, and 6.6. The time of sinking in seconds is represented in the vertical axis. You can see over here that each of the mass of boat and average time of sinking is represented as a data point, or the dot over here, here, and here. You can see from the table that as the mass of the boat is heavier, so there is a greater mass, then the average time of sinking decreases from 4.9 to 4.2 to 3.9. And you can see this from the downward sloping relationship between the mass of the boat and the time of sinking. So as the mass of boat increases, then the time of sinking decreases. And overall, this is the format of the line graph where the series of different numbers or data points are connected by straight lines on these horizontal and vertical axes. But you could see over here that not only are these lines connecting to the data points, but there is this other line. This is because looking at only this thicker blue line, you can see when is the maximum or the most time needed for syncing, which is when there's 1 dime, compared to when there's 3 dime, there is the fastest time of syncing. And overall, because you have these different straight lines connected, you can probably predict when or what is the time for syncing for example, when there is 3 grams for the mass of the boat, which would be over here about 4.6. But then you can see that this graph isn't straight. And so what you can use when you're more advanced is a trend line. And this trend line shows an average of all of the data points you collected and see an average slope or a trend that shows the overall pattern of what will happen if there's different masses to the sinking time. And you can see that although this trend line does not pass all of the data points, it better shows the overall downwards or negative slope, showing that there is a relationship where an increase in mass of boat would result in time of sinking. So today overall we've seen 2 different types of graphs, which are the bar graph over here, where we use when we have different variables or different types of things that we want to compare against. However, when we want to compare different amounts of one thing to another, such as different mass of boats to time of sinking, we call this trying to look at a direct relationship. We use a line graph. And better off, we could use a trend line to represent the relationship of the different data points. So today we've been looking at 2 different types of graphs as well as using data tables before we create graphs to understand what it really means to look into the numbers we collected. So I hope you now understand what bar graphs and line graphs are used for and how to create data tables on a basic level. If you have any questions, please feel free to write in the comments or email us, and we'll be back on with explaining other types of graphs for you guys. Thank you.